Hi, in this video we are going to talk about one of the questions of searching. So when we talk about searching, there's linear search, there's binary search. So in this question we will see which particular search we have to do, and in case you already know binary search, then this question will be pretty easy for you. Plus this will give you a practice of binary search, and to some extent we will see that how we can modify to some extent binary search to get our results. So we will do the drill. First we'll try and understand the question, then we will try and come up with the logic, and then we'll just try and write the code. Okay, so let's just go ahead and try and understand the question first. So as you can see, this is transpoint question at mycode.webbytes.com. Okay, let's go ahead. So the question says, Tina is a computer scientist and a part of her work requires her to find the first occurrence of 1 in the array consisting of 0 and 1. So I'll just note down the important point. I'll just underline first occurrence of 1 in the array consisting of 0 and 1. One good news is that the array is sorted. Okay, good. Tina is sure that a sorted array will give solution to this problem in more efficient way. Can you write code to find first occurrence of 1 in the array consisting of 0 and 1? So as you can see, the problem statement is pretty much simple and very clear and very simple. It is written that you will have an array consisting of 0 and 1. The array is sorted, which means that all the zeros will come first and then we'll have all the ones. We have to find the first occurrence of 1 in the array. Let's just see the input, output and the test cases. So in the input, the first line contains an integer t, which is number of test cases. Then follow t test cases. Each test case consists of 2 lines. First line contains n, length of the array. Second line contains n space separated integers 0 and 1. In case of output, we have to print t lines, each containing index of first occurrence of 1 if it exists, else print -1. So it could be a case that we have a complete array of just zeros, there is no 1. In that case, we have to print -1. Now let's see the test cases. In this case, we have t as 2, which means we'll have 2 test cases. We have length as 5. We have 5 space separated integers. The first one occurs at index 2, and then we have 4 as the next test case. The length of next test case is 4. We have zeros, which means there is no 1, hence the output is -1. So I hope the problem statement is pretty much clear to you, and the constants say that t will have value in this particular range and n will have maximum value of 5 into 10 to the power 6, and as it's written that a of I could be either 0 or 1. So that's the test case. Let's just go ahead and see how we are going to solve this problem. Okay, so we have seen the problem statement. I have just written that down in one line. So you are given an assorted array of length n consisting of zeros and ones. You have to find the first occurrence of index of 1, or you can say find first occurrence index of 1. Okay, now let's write it down. So let's say we have an array 0, 0, 1, 1, 1. Okay, so one obvious option that we have is that we go through each and every element of the array, and what we will do is we will just try and find out which is the first one. Okay, so in that case, I'll just run a loop from I equal to 0 to n minus 1, and I'll check each and every element, which so every element is having value as 1. The first element, that is going to be my index. So that gives me a time complexity of O of n in worst case. When I say worst case, which means that let's say what if 1 is there at the end of the array, or in let's say 1 is not at all there. In that case, you will have to go through the complete array. So your worst case time complexity will be O of n. So if you try and write this code, the code is fine, but when you will submit it, you will get time limit exceeded. So in such cases, when we get time limit exceeded, we have to reduce the time complexity. This is the time complexity. So as I said in the beginning only, that if you are aware of binary search, then you will be able to solve this problem in O of log n. But for that, you have to be good with binary search. You have to understand what is binary search. You should be able to write code of binary search. Okay, if you are still not clear with binary search, I'll just suggest go back and see the video of binary search. Okay, now let's say how do we implement binary search in this particular thing. So what we will do is we have to find the first occurrence of 1. Okay, so what we will do is we'll check the mid element. Okay, so like we do in binary search, we keep on dividing the array into halves. So we'll check the mid element. So what are the several situations? Number one situation is that mid element is 1. Another situation is that mid element is 0. So in case mid element is 1, there are again 2 situations. One situation, as you can see here, when I say mid, the mid will keep on changing in the program. Okay, so as we keep on applying binary search, the mid will keep on changing. I'm just taking a generalized case. Okay, So let's say we have 0, 0, 1, 1, 1. Another option that we have is 0, 1, 1, 1, 1. Okay. So in this case, this mid is actually the index that I am supposed to return. So what I'll do is, in case my mid element is 1, I'll check that if mid minus 1 is 0. That means that this is the first occurrence of 1. I'll repeat, whenever I get 1, I'll check that if previous element is 0, in that case this is my answer, I'll return the mid. Else what will happen is that in this particular case, we know that all the elements after here are just going to be 1, which means that they are not going to give me the first index. First index of 1 lies somewhere in this particular half. So what I'll do is, I'll apply my binary search to this particular half. So I'm talking about that if mid is 1. So these are two test cases. Let's say mid element is 0. So let's say we have 0, 0, 0, 0, 1. Okay, so let's say this is my case. In this case, let's say first this is the mid element. In this case, what will happen is that there is no chance, since this array is sorted, that 1 will occur somewhere in this particular area of this array, right? So what we will have to do is, we'll have to start searching in this particular area. And this is something that we have to keep on doing. We'll have to keep on updating. So now this becomes a new array in which we have to find for the first occurrence of 1. Okay, so this is what we do in case of binary search. We keep on dividing the array into halves. We just reject the half that we think is not going to give me the answer, and we just pick up the half that we think is going to give me the answer. Accordingly, we just update our start, end, and mid accordingly. Okay, so I'll just repeat that if you're not clear with binary search, just go ahead and watch the video of binary search first and then come back to this particular video. Okay, so now we have come up with the approach to some extent. We will find mid. Okay, and mid is going to be start plus end by 2. Okay, so what will happen is that start will always be the start of the array, starting index of the array or the subpart of the array that we're talking about, and end is going to be the last one. So in this case, initially my start will be 0 and end will be 4. But as we divide our array, then my start becomes 0, 1, 2, 3 and my end becomes 4, and then accordingly we'll have our start plus end. And one more thing I would like to tell you is that it's always better to keep calculation of mid as start plus end minus start by 2, because this to some extent ignores the integer overflow. Okay, so again we have explained this while talking about binary search, so make sure you watch that as well. Okay, we'll proceed further. So we'll calculate mid. We'll check that if mid is equal to, if a of mid, let's say a is the array, is equal to 1. If it is equal to 1, we will check that if arr of mid minus 1 is 0 or not. Before that, there is another situation, or there is another condition that we need to keep in mind. What if the array is something like this? Okay, in that case, what will happen, or let's say is that in this case what will happen is that we will come to a place where our mid becomes 0, and this one we come to this particular place. In this case, if we check that arr of mid minus 1 should be equal to 0. If we check this condition, we will get runtime exception, because this is, we are trying to access a negative index. Okay, so what we will do is that whenever we get a of mid equal to 1, before we check this condition, we will check the condition that mid should be equal to 0, or arr of mid should be equal to 0. So what happens in this case is, we check if arr of mid is equal to 1. Yes, it is 1. Then I check that whether it is the leftmost element. So what happens is that this is OR. You must know this. In case you don't, no worries. So this is OR. In this case, what happens is that if this becomes true, then we don't even evaluate this particular part. So this is how it happens, that as soon as this becomes true, since in case of OR, what happens is that if any of the one is true, the answer is true. So as soon as we get this element as true, we don't even evaluate. The compiler does not even evaluate. So as soon as we get mid equal to 0, this does not get evaluated. This will be mid minus 1. Okay, so what will happen is that we don't get the error that we were talking about here. And in case mid is not equal to 0, we check that arr of mid minus 1 is equal to 0 or not. In case this is true, this whole thing is true, which means we are somewhere at this particular place, and we will simply return our mid. Okay, And if this is not the case, let's say this condition is not true, another condition we have is that if r of mid is equal to 0, in that case we will make a recursive call. If a of mid is equal to 0, we'll do our searching. In this case, what will happen is that we are here at this particular place. We have to search in second half. So what we will do is, we'll update our start to mid plus 1, and I'll update our end to as it is. Our end remains as it is. This is one situation. Another situation is that if this situation is not true, this situation is not true, the only situation remaining is this, which means that we are somewhere in this kind of array. In that case, what we will do is, we have to search in first half. So we update our end to mid minus 1, and I'll start remains as it is. Okay. So now many questions will be coming in your mind, that what is going to be the base condition, and what does this mean, how we are going to just pass start and end, and how things are going to happen. So now again I'm repeating, if you're clear with binary search, these kind of questions might not be coming in your mind. You might be somewhere clear with the code, but let's say if it is still coming, no problems. Let's just try and write down the code. Okay, so first just write down a generalized code, and then we'll write it in the corresponding language. Okay, so we have seen till now the logic. I'll just repeat it once before we just go ahead and write the implementation thing completely. So what we will do is, we'll have a mid, we'll check that if the mid is the right index, we'll simply return it. Else we'll make a decision based on certain situations that we have to search for the first index in first half of the array or the second half of the array. Let's just go ahead and write the code for this. Okay, so let's say the code is let's say the function is first index. What are going to be the parameters? We have already seen that we are going to have an array. So one of the obvious parameter is the array. Okay. Another thing is start, end. Okay. So these are the things that I'm thinking will be useful right now. Okay. Now what is the base condition and what is the return type? So we will be returning the index. So the return type will be int. It will be the index. We'll check that if this is the base condition, start is greater than end, you simply return -1. So we have to return -1 if there is no 0, if there is no 1. This is the case, okay, that we keep on searching, and in this case, if there is no 1 present, then we eventually will come to a place where start becomes greater than end. In that case, we simply return -1. If that is not the case, we will check if r of mid is equal to 1 and mid is equal to 0, or r of mid -1 is equal to 0. In this case, I'll simply return the mid. Okay, fine. Another situation we have is that else if r of mid is equal to 0. Okay, we haven't calculated the mid, I'm so sorry. So we'll have our mid, int mid is equal to start plus end minus start by 2. Okay, that is our mid. Okay, coming back, we check if r of mid is equal to 0, which means that my first index of 1 is in the second half. So I'll simply call this first index again. I'll call first index, and I'll just go across, I'll pass the array, I'll parse the start. So in this case, the start will change, the start will become mid plus 1 and the end remains as it is. And if none of the condition is true, which means that, let's say in this case, we are here and we have to do our searching in the first half. So we will simply return, we have to do return here, okay. We will simply return first index r comma start comma mid -1. So in this case, our end will get updated. So that is the code. So we have seen the code completely. The only thing that we need to do is that we just need to write in the corresponding language. One thing you must see is that first we tried to come up with the logic. We did some calculation part, or you can say pen and paper part. Then we just wrote down the steps in English so that we are clear with what steps we have to do. And just after that, you can just go ahead and write the code in whichever language you want, but we just add a intermediary step as well. So in case you're not able to directly write the code in your compiler from the steps that we did, in that case, just write this intermediate code, just write the code on using pen and paper. That's going to help you. Now let's just go ahead and write the code. The time complexity for this code is going to be O of log n. Okay, and in case you are doing the question of searching, I'm assuming you must be clear with recursion till now, and in case you aren't, see what is the issue, again try run the code. Okay, so let's just go ahead and write the code. Okay, so till now we have seen the problem statement, we have understood the logic, and we have seen how we can write the code, and we have written the code pretty much. It's just that we have to write it in Java and run our platform. So let's just go ahead and write the code in Java. So I've already taken t as input, and for every test case I'm already taking n as input, and I'm taking the value of arrays as input. And what I'm doing is I'm calling a method find1, and this method will give me the index of the first occurrence of 1, and I'll be simply printing that index. This is the find1. This is giving me an error because we don't have anything to return right now. We are not returning anything, so this is giving me an error. So let's just go ahead and write the code. So we'll start with writing the base condition, and the base condition is that if start is greater than end, we simply return -1, which means there is no 1 in the array. Okay, and what we will do is, if that is not the case, I'll calculate my mid. Int mid is equal to start plus end minus start by 2. Okay, now I have to check the value of mid. Based on that, we'll decide further course of action. So we'll check if a of mid is equal to 1 and mid is equal to 0, which means this is the leftmost element, or a of mid -1 is equal to 0. This means that this is the first occurrence of 1. In that case, we'll simply return the mid. Okay, else we will check if a of mid is equal to 0. In this case, what will happen is that we know that if mid is equal to 0, which means that there is no chance that we'll have 1 in first half, so we'll have to search for the second half. So in that case, we'll update our start. So we'll call the find1 function or find1 method. We'll have our a as it is, we'll have our start as mid plus 1, and our end will remain as it is end. Okay, and if this is not the case, which means we are at a place where we have to search in the first half of the array. In that case, we'll simply return. In this case, we'll have a return as well. In that case, we'll simply return. I'll copy this. This remains as it is, start remains as it is, and we'll make this mid -1. So this is going to be my code. Let's just run this code and see that if we are getting the right results, and then we'll submit it on the platform. So let's see, 3 is the test cases. We have 5, 0, 0, 1, 1, 1. Okay, this is giving me 2, which is right. Let's just try some test case. This gives me 1. Again, for 1, we have 1. Okay, so I'm getting the right responses. Let's run this and see if we are getting the code as accepted. So we'll just change it main. We'll submit the code. Okay, so we get our answer as accepted. So make sure you're trying the code on your own. Make sure you're writing the code, and make sure you understand this whole modified binary search really well. And if you are someone who couldn't come up with the logic and is kind of anywhere confused that how this or that is happening, make sure you write the code on your own and you dry run the code. That is really important. Just see one array and see how mid is changing, start is changing, and how values are getting returned. Okay.